Hello everyone, my name is Abhijit Borgule from Gwangju Institute of Science and Technology, South Korea. Today I am going to present our work on on-device face authentication system for ATMs and privacy preservation. The main goal is to introduce face recognition based authentication to ATMs to avoid fraud and crimes caused by card and password information theft. There are several challenges are associated to build such a device that should be able to efficiently recognize the face during the financial transaction. So the main challenges are a user's face should be verified without using expensive GPUs and server. Second, these IoT devices should perform accurate face recognition. And finally, the ATMs are in limited computational resources, so they are only designed for financial transactions. So it is not feasible solution to use ATMs computational power to perform the face recognition. So here we develop two-step authentication system. First, a face is recognized and the PIN authentication is performed to perform the final transaction with the bank. So here is our motivation. Consider when a thief uses a stolen card and its information to withdraw money from ATM, which is a serious loss to the actual user. So our main motivation is to avoid fraud caused by card theft. Previously, due to the lack of ATM processing power, many conventional algorithms have been introduced with cloud server to perform face recognition, and there are several other important issues with existing system. A banking organization may have millions of active accounts, and as a result, millions of faces must be stored on the central server. And many users are concerned about their privacy, so uploading a vast number of faces to the server is not an option. So ATMs are shared with different users from different bank, which again raises the complexity of all the faces to the server. So deploying face recognition based authentication at large scale is very challenging. As you can see in this figure, a banking server communicates with multiple banks using different banks' ATMs. So here is our general face recognition pipeline. So here we will see how the face recognition works. From the input RGB image, the first face is detected and then the face alignment algorithm is applied to crop the exact face area. A deep neural network projects the face features into hypersphere representation. And finally, we compute the similarity of all faces with registered faces. So here we present how our device functions with the ATM. In general, a thief inserts a debit card of the another person to withdraw money from the ATM. In our proposed system, we retrieve the card information along with the actual user face features and compare them with the camera features before proceeding to the financial transaction. So here is our detailed proposed architecture. We have converted the face detection and recognition model to fit into the TensorFlow Lite format and integrated those models into the HTPO system on the module. In this multi-threaded architecture, camera thread 2 records the image frames from the camera and queues to the main thread 1 for face detection, alignment, and recognition. If a user is present inside the camera scene, then we compute its facial features and request the user to insert the credit card or debit card inside the ATM. A smart card reader from the ATM reads the encoded face feature along with the banking information and forwards it to the face recognition module. The result is communicated with the ATM for further processing. So our face registration is as follows. First, an actual user's face is detected via HTPU and the deep learning model extracts the face features. The extracted face features are then encoded into to fit into the smart card chip, and then smart card writer stores the information inside the credit or debit card. So during the face recognition, when an unknown user appears at the camera scene, our system detects the face by using same trained deep learning model, and it generates the face features. Simultaneously, a smart card reads the face features from the card, which are compared with the detected face features. If a distance is matched in the threshold, if a distance is matched with the threshold beta, we proceed for PIN verification. This way, we have designed a two-step authentication for ATM machine by not using expensive GPUs and servers. So here are the experimental results. To test the performance of our face recognition model, we have considered 10 candidates, which is from 10 debit card users, and same test candidates at different time. Our confusion matrix shows that the distance generated by the face recognition model shows the better generalization performance. In an actual scenario, there will be always one-to-one matching, which significantly help face recognition model to accurately compare target and candidate faces. So here is our conclusion of our proposed system. We have proposed a face-based authentication for ATMs and financial transactions. Our system does not require expensive GPUs and cloud servers for face recognition. By introducing smart card memory as a storage medium for the face, we have resolved the issue of privacy preservation. And the entire algorithm is optimized to run on dual core processor with 1 GB RAM, and these IoT HTPU devices can be used with multiple ATMs. An experimental result shows that on one-to-one verification, our system has achieved significant performance. We also plan to extend this work by introducing infrared and depth camera to further increase the face recognition accuracy. Thank you for listening. Please email your query and question at our displayed email ID. We will be happy to talk with you. Bye bye.